Alright, this is my update on the solar panel controls, and now we have the ability to sense 3 different light intensities, so we're able to kind of triangulate the sun's position. How we're going to do this is we're going to have a sensor that I used in the previous video. This time we're going to have 3 of them now, and we'll have kind of a shield, such as kind of like this is a good example of able to block the light, and as you can see you get shadows in certain areas based on the location of where the sun is, that being my light here. So I'm going to use this principle to help us locate the sun at any given point in the day, and we're going to do that with these 3 sensors here. So they're photo or resistors that change their resistance based on light. And so we have this microcontroller. It's reading the values that these resistors have, probably like 80 times a second or something like that. And then here we have all these wires coming over here are going to control the motors, and this is basically the motor control board over here. We have 2 stepper motors, and this one, it will be adjusted based on the horizontal position of the solar panels, if you will. So based on the difference between this one and this one will rotate to a new position. And then this one, this motor will rotate based on the difference between the sum of these 2 and this one, or I guess the average of these 2 versus this one. So it's comparing these 2, and based on, so that would be your vertical axis. So this one will adjust based on the difference between these 2. And all this is being sent to through the serial port, and it's being recorded here in the terminal. And we got each column will be a different sensor. So I'm going to put my finger over the one of them, and it'll go down. Let's see here, which one is that? That's going to be the leftmost one. Kind of went down in value. Or the rightmost. So it's sensing this real time. So yeah, let's give it a shot here. So first I'm going to cover up, this will be like simulating the horizontal alignment, which will be this motor. So I'm going to cover up one of these, and it's going to rotate it one way, and cover up the other, and it's going to rotate it the other way. This is basically just showing the principle. These motors are not big enough, obviously, to drive anything very large, but this is going to, the principle is the same. So that's based on these 2 that I'm covering up. Now, if the vertical alignment's off, say these 2, first of all, these 2 must be satisfied before this one will even move. So if one of these is off and I try and cover up this thing, it's not going to do any. It's not going to move because we're not satisfied over here. Once these 2 are satisfied, say they're equal, and if I cover these up, say the solar panel is facing up too high, so these would be in shade, and this is going to rotate it. Now let's say the solar panel is too low, so the bottom will be in the shade. I'm just going to rotate it up, and this will follow the sun. We can have it, these can actually lock their position, but we don't want it to do that for the solar panels because that'll waste electricity. So when everything's fully satisfied here, these are free to move, so it's not burning any electricity while it's stationary. It's still sampling, but this doesn't take hardly any electricity to run. This will be able to run on very low power, and if we say we only want to update these every 30 minutes, it'll check it every 30 minutes versus updating real time like it's doing here. Well, that's all I have.